Okay, we're back. I hope you enjoyed those videos on. Now let's see what happened. Like when you saw the school kids. I wanted you to watch videos 3, 4, and 5 there. They were short and they were pretty entertaining. But what happened when? And I don't like using the slideshow to be honest with you on this. So, well, here's what happens with the ping pong cannon. And basically, what we're doing is they said in the MythBusters thing, we're reducing that, and 1100 meters per second or 300 miles an hour. We were doing that in our lab. Ours didn't go near that fast because we didn't have that good of a vacuum in here. But you get that 14 pounds per inch back here, nothing in front of this ping pong ball. Whoom, suck all the air out of it. It flies out of there pretty fast. Now, what happened with the can crushing when you saw the students? Or the first video I showed you was the train getting crushed. Well, what that was, I just know what that was. That what they did was they had all these vapors in there that started to cool. That it was probably filled with fuel. They didn't vent it. They sucked all the vapors out. They sucked all the gas out. It was left with nothing but gas vapor. And then when that vapor cooled, that created and plus gas is much less dense than the outside of the can. So here, the gas inside of that rail car was much less dense than the gas inside, crushed it. Now with the regular can, what happened was you heard the young lady with that 55-gallon drum. What she did, they cooled it down, and they filled it with steam. They heated it up, filled it with steam. All right, and when that steam cooled, turned to water vapor. That was much less dense than the air, and so there's much less material inside here because it was inside a vacuum. There was no air able to get in. It wasn't vented because remember they sealed it off, and so when that cooled, became much less dense out here, much greater out here, and it crushed. So the reason it did was the pressure inside the can decreased, so it got crushed. It wasn't the metal quickly cooled. What happened was and they didn't bother to turn that thing upside down. What happened was the metal didn't quickly cool. It's the air inside that quickly cooled. All right. So pressure of water. Pressure of water is very intense. It's very high. Okay. And the pressure of water, because look at its density. Air had a density of 1.2 kilograms per meters cubed. Notice it's meters cubed, so we're talking about a volume here, kilograms per volume. All right, mass per volume. That's density. All right, water's 1,000. Water is 1,000. That's why when you dive deep in the pool, it hurts. Or on an airplane, it hurts. Why? Because the pressure inside your head is higher than the pressure outside on the airplane. So on an airplane, it's getting pushed this way and it hurts. When you go underwater, it's getting pushed that way and it hurts. Okay, because the water is filling up your ear and you're under intense pressure in the water. And so you got scuba diving and snorkeling. Now, is it possible for you to have a long tube instead of using scuba gear? Could we go deep underwater using a long snorkel? And the answer is no. As we go under the water, the pressure increases due to it goes up 1 atmosphere for every 10 meters, ballpark. So it goes from, when you get 10 feet below, it goes from 1 atmosphere, which is 15 pounds per inch, up to you go down 10 meters, 33, which is quite a ways. Go down 10 meters, it's now 30 pounds per square inch. It's doubled. And so what happens is you can't breathe. You can't breathe. So which dam must be stronger? It's all about depth. It has nothing to do with crossways. If this is a large shallow lake, I don't care if this goes out for 300 miles this way. It doesn't matter. You need a thicker base here at the bottom for this one. All right. So we'll break here because I need to shorten this up into short bites so it'll work. And I never did turn it on. I don't think. Oh yes, I did. Good. I was getting ready to have a moment there. I thought I'd forgot to record it. And all that brilliance of mine went away.